Controllers and control theory. This presentation discusses general operating principles and presents guidelines for selecting control instruments. Controllers are used in oil and gas production operations to regulate parameters such as temperature, pressure, flow rate, and liquid level. Controllers usually measure one of these process parameters and then send out a signal to another element in the system. This element, for example, may cause a fuel valve to open or close in order to bring the process variable to the desired point. In a simple operation, it may be possible for one operator to manually deal with all process variables and control them. But as the process becomes more complex or spread over a large area, it then becomes more than one operator can manually control. In such cases, automatic process controllers are installed. All automatic process controllers contain a primary element, a transmitting element, a controller, and a final control element. Here, we see a simple system for controlling water in and out of a holding tank. The demand on the tank causes the water level to drop and consequently causes a float in the tank to drop as well. This float is the primary measuring element of our simple system. The primary element is the part of the system that detects the process upset or change in the value of a process variable. The primary element is linked to the transmitting element, which converts the motion of the primary measuring element into either a pneumatic or electrical signal. This signal represents the value of the process upset and is sent to the controller. At the controller, process upset signal is compared to the value of the desired set point. Now, the difference is computed, and another output signal is then sent to the final control element, in this case, a valve. This output signal is proportional to the corrective action necessary for the valve to bring the process variable, the water level, back to the set point. Depending on the process, control systems may consist of feedback control, feed-forward control, or a combination of feedback and feed-forward control. A feedback control system, for example, is shown here. The desired temperature of the water in the tank is controlled by a feedback mechanism installed at the water outlet. This mechanism ultimately controls the fuel supply of the gas-fired heater. If the temperature of the output water is too hot or too cold, the amount of fuel gas going to the heater will be reduced or increased accordingly, thus bringing the temperature to set point. In an automatic feed-forward control system, a temperature-sensing transmitter element would be installed in the water inlet, as opposed to the water outlet of the feedback system. If the temperature of the incoming water changes, a signal is detected by the measuring element, which is also a transmitter. The transmitter sends a signal to the controlling element, where it is then compared to the set point. If a difference is noted, the controlling element sends a proportional control signal to the final controlling element, the gas supply valve of a gas-fired heater, then increases or decreases the temperature of the fire tube. The result of this feed-forward control is that the temperature of the controlled variable, in this case the temperature of the heated water in the vessel, will be consistent. In a feedback and feed-forward control system, two control systems are used to sense the temperature of both the inlet and outlet water temperature. Depending upon the installation requirements, controllers can be set up either on local or centralized basis. A local controller senses the process variable directly and commands a valve or other device to adjust the process variable. Examples of local controllers are a level controller mounted on a vessel, a flow controller connected to an orifice fitting, or a pressure controller mounted on a valve yoke to sense the process pressure. In a central control system, all controllers are concentrated on a control panel, usually located in a central control room. Small installations usually lend themselves to local control. For medium-sized operations, a combination of local control and central control may be more appropriate. In such a system, less critical parameters are controlled locally, while only the critical parameters are controlled by the central system. Most large facilities today use central control systems. Selection of control systems depends upon the process, operating philosophy, and personal preference. The text that accompanies this presentation explains the principles of control and presents guidelines for selecting control instruments for various processes and their methods of implementation. After viewing this introductory video, please follow the sequence outlined here. First, read the process explanation. Then, review the equipment description. Finally, study the design theory and procedure.